So directly related to the fact that the Earth still has a lot of its original thermal energy from when it was first formed. In fact, it's big enough that it hasn't cooled down like Mercury and the Moon has cooled down, so it's geologically active. Related to that, actually, is why the Earth has this really beautiful, what we call a magnetic field. Specifically, we call the magnetosphere. And magnetic fields can be created by charges in motion. So specifically, you could take a battery and run a current through a copper wire, and take that copper wire and run it around something cylindrical like this, and we would actually create a magnetic field. And a magnetic field is represented here in both these figures by kind of this pink, what we call lines of flux originating from magnetic north, and I think it originates from magnetic south and enters magnetic north. These are flux lines, okay? So we can create a magnetic field with moving charges. So what does that have to do with planets? Well, if our planet is large enough and has not entirely solidified, what'll happen is within its core region, so kind of have to draw your attention to the gray area of the Earth, within its core we also have some liquid part to the Earth's core. And the Earth's core is mostly made up of iron. And so it's this liquid iron that is actually in the form of, I want to say ions, but the spinning molten iron actually is what creates a humongous magnetic field for the Earth. So if our Earth had cooled down like Mercury and the Moon, even though Mercury's spinning, it doesn't have a magnetic field like we do. Yeah. So I think we talked earlier in this course the significance of Earth's magnetic field, but we're going to hear it again. So here we have the Earth, sorry, over here yellow we have the Sun, and the Sun is radiating energy, but the Sun is also literally is creating in all directions what we call solar wind, and all stars do that. It's a positive pressure, and in that solar wind are charged particles. And honestly, those charged particles can be very harmful to life if we were to be exposed to those charged particles in the solar wind. So here we go. Here's the Earth, and if you kind of get a sense of scale of this, I mean, the Earth is very small here. You can see around the Earth are these two purple rings we call actually the Van Allen belts, and it's got kind of this blue sort of ghosty-like regions that we call the magnetosphere, or that's the Earth's magnetic field. And so the magnetic field actually will deflect, and in the case of the Van Allen belts, it will not only necessarily deflect, but it will kind of collect any charged particles that get as far as those belts. So this is our protection from the Sun, basically. And actually it is, if the Sun is sending extra doses of charged particles in its solar wind, what happens is those Van Allen belts that I said, those purple things on here that kind of collect extra charged particles that get that far, they'll be to capacity or over capacity. And so in that case, what will happen is they will leak charged particles into the north and south magnetic pole, which is just slightly off a few degrees from Earth's axis of rotation. But anyway, so it's those charged particles then that eke through the charged particles then that make it through our magnetosphere into the Earth's atmosphere, then that glow like this and give us our northern lights and southern lights.